Alright, we'll just pick up where we left off here. We're on page 15 of 2.2. We were on E. Let's do a quick recap because I know I just did it in the end there. So again, we check our values. Remember, we do the arc sine of the value to get the angle. We get 90. You can check the other one there is 270. Would also give you back 0, right? Okay. And then the last one, obviously this is a decimal 2372, which doesn't have a value. So there's no way to do this without using a calculator. You have to actually calculate this in. So we know it's positive sign. So our reference angle is going to equal our quadrant 1 and our quadrant 2 angle. All right. And you can do one place after the decimal here. So it's decimal 2372. So the inverse sine of decimal 2372. And we did this in grade 11. Now we're just looking at it. So there's your angle here. All right. So to get the other angle, remember we take the 180 and we minus that angle, our reference angle, and that will give you the reference angle that goes with it, 166.27. And if you take the sine of second function answer, so the sine of that angle, that should give us back 2372. Again, it's going to be approximate. It's not going to be exact values. But in this case, it was obviously because I put in I kept everything in my calculator, but as soon as you round, then you wouldn't get exact. But it'd be close enough to check. All right. Let's look at G. So we have tan theta. Again, it's done the same way. Remember, to get the reference angle, drop the negative here. Just take the inverse tan of the decimal. Don't put the negative in. That'll be your reference angle. And then we know that your answers will be, for tan to be negative, would be quadrant 2 and quadrant 4. All right. So let's grab those values. We'll check that now. So inverse tan. This is the way I like to do it. I'm decimal 2368. Remember, make it positive. That'll give you the reference angle, 13.3. We know we're looking for the angles in quadrant 2 and 4. So to get the quadrant 4 angle, we take 360 and subtract that answer. And there's your angle for quadrant 4. And to get the quadrant 1 angle, obviously we take 180 and subtract the 13 decimal 322, right? We get this 166. Again, just round to one place, so 166.7. As you can see here, quadrant 2, quadrant 4. All right, let's look at H. We have sine of an unknown angle is equal to negative decimal 2710. So again, I drop the negative, take the inverse sine of decimal 2710. So go to your calculator. Second function, sine decimal 2710, 271 equals 0. You don't need it, obviously. There's your angle. So that's reference angle. But remember, it's negative. So if it's negative, sine, we're looking for quadrant 3 and 4 because it's positive. You look back, remember, positive here. So there's our reference angle. We're looking for the negative, so that's going to be quadrant 3 and quadrant 4. So if you want to look at your reference angle sheet, so remember, our reference angle, again, this is what's going to be an approximate. And it was 15.7, right? Again, this is just be 15. So if we're looking for a reference angle 15, we're talking the 195-ish, and 15 here, we're talking 345-ish, and that's where these values come from. So basically, to get the reference 3 angle, you take your 180 and add your reference angle, and if you have quadrant 4, you take 360 and subtract your reference angle. And that goes all the way back to what we learned in the section 1 decimal. There we go, right there, right? Section 2.1. Reference angle is equal to theta. The reference angle is equal to 180 minus theta, right? So theta would equal to yeah. That's how you calculate it, right? Okay. So just be mindful of that. And we'll third, sorry. And then we get to I cos of theta is equal to negative decimal 1872. So drop that to get your positive and your reference angle in quadrant 1. So the inverse cos of decimal 1872 is going to give me 79. But this is not an answer that we want. We want the negatives. We know cos is negative in quadrant 2 and 3. So we're going to take the 79.2. We're going to subtract it from 180 to get to quadrant 2, and we're going to add it to 180 to get quadrant 3. This one's kind of neat. We got the square root. Sine squared theta is equal to 1. So first thing we're going to do is take square root of both sides. So we get sine theta is equal to square root of 1/3. And again, you can just put this right in the calculator, right? So we get second function sine, right? So the inverse sine of the square root of 1 divided by 3. It's the whole thing this time. Enter, and we get 35.26. So your reference angle is decimal 35. Alright, I just had to fix that little typo there. Remember, when we take the square root, that will leave plus or minus. So that means that we're dealing with all quadrants for an answer. So we'll start by that. So your reference angle ends up being 35.3. So that's quadrant 1. Quadrant 2, we subtract that from 180, and we get 144.7. Then we take, to get the quadrant 3 answer, we add 35.3 to 180 to get the 215.3. And then to get the quadrant 4 angle, we take the 360 and subtract our reference angle of 35.3 to get 324.7. So anytime you take the square root of both sides, remember that can be plus or minus, so that would include all angles to give you back one or the other, right? The plus or the minus. We know the quadrant 1 and 2 will give us the plus square root 1/3, and we know that the quadrant 3 and 4 for sine will give us the negative square root 1/3. All right, so be careful with that. So again, just a summary of how to find the principal angle. I think this will be important. Is quadrant 1, all are positive, so theta is equal to your reference angle. Quadrant 2, sine is positive, cos and tan are negative, so your theta is equal to 180 minus your reference angle, or your reference angle, if you take it over there and over here, it's 180 minus, regardless, right? Quadrant 3, we have tan is positive, sine and cos are negative, so our theta is 180 plus our reference angle here. And if we're looking for a cos that's positive and your sine is negative and tan is negative, that's quadrant 4, which is 360 minus reference angle. So homework here is page 97, numbers 9, 13 to 16, and 29. That's actually all we're going to do for chapter 2. Last year they moved a couple of sections from Pre-Cal 12 into Pre-Cal 11. You'll notice in our textbook, if you're following along the book, you'll notice that 2.3 and 2.4, if you look, are the sine law and the cos law. We've done those already in Math 11, so we don't need to do those. So that's actually it for the chapter 2. It's only 2 sections. I don't know if I'll have time, but I'll try to put some videos together for what I call 2.3, which is actually 4.1 from Pre-Cal 12, and 2.4, which is actually 4.2 from the Pre-Cal 12 book. We'll do those in Pre-Cal 12 next year. They have not prioritized those outcomes because of obviously our year being cut short. So this is all you have to do for the for chapter 2 trigonometry for Pre-Cal 11 at this point in time. We will go to do the 2.3 and 2.4, which are actually 4.1 and 4.2 in Pre-Cal 12. We'll do those in grade 12 anyway. I do them as a review regardless. So you're good up to this point. It's just the 2 sections. This one's a little larger again. That's it for the videos for trigonometry chapter 2. Thank you everyone, and we'll talk soon.